the solutions for the Unit 1 quiz. That way, if you have questions, hopefully we can clarify some of those issues. So in Canvas, what I did was I set the rubric, and this was kind of after the fact, after you guys took the quiz, but I scored the first question out of 4 points, the second out of 3, and the last question out of 2 points. So I'm going to go through this and I'll tell you where those points came from. In combustion analysis, remember, you have a hydrocarbon, and sometimes it's just carbon and hydrogen, and sometimes it has something else. And I know this one has oxygen in it because it tells me this particular compound is made of C, H, and O. Then that hydrocarbon reacts with oxygen from the air to produce carbon dioxide and water. And the question tells us that we have 1 gram of this vitamin C, and when it burns in air, it produces 1.5 grams of carbon dioxide and 0.41 grams of H2O. So the first step is to convert the carbon dioxide and the H2O to moles of just carbon and moles of just hydrogen. So we'll do that by first dividing by the molar masses, respectively. And then the mole ratio of carbon dioxide to just carbon is 1:1. And for this, I get 0.034 moles of carbon. Need to repeat the same process for the hydrogen that's present in H2O. So I will divide by the molar mass there. And then the ratio of hydrogen to oxygen is hydrogen to water. For every 1 mole of H2O, there are 2 moles of hydrogen. That's because to H2O. And for this one, I get 0.046 moles of just hydrogen. Now, if this hydrocarbon just had carbon and hydrogen to it, I would be to the point where I would divide my moles by the smallest to establish a ratio. However, this hydrocarbon also has oxygen in it. So we are going to have to go the extra mile, which means we need to do another step to figure out how many moles of oxygen were present from this hydrocarbon. There's no way to determine that straight from CO2 and H2O because that's 2 products that contain oxygen, and there are 2 sources of oxygen in the reactants, and I don't want to know how much oxygen is here. I need to know how much oxygen's in the hydrocarbon itself. So to do that, I need to take these moles of carbon and hydrogen and convert them to grams. So I'll just multiply by their molar masses. The molar mass of carbon is 12.011 grams per mole. And that gives me 0.408 grams of carbon. Do the same thing with the hydrogen, 1.008 grams per mole. And for the hydrogen, I end up with 0.0464 grams of hydrogen. Now that I know how much carbon and how much hydrogen by mass are in this hydrocarbon, I'm simply going to subtract those 2 numbers away from the hydrocarbon. Because if I get rid of the carbon and the hydrogen from this 1 gram sample, the only thing that's remaining is the oxygen. So just subtract those away. Minus this should be an 0.0464. And this gives me that I have 0.546 grams of oxygen present in this hydrocarbon. I need everything to be in moles. I already have moles of carbon, moles of hydrogen, but I need to convert oxygen to moles. So I'll divide by the molar mass of oxygen for 1 mole. And I find that this is 0.034 moles of oxygen. Now that I have moles of all 3 elements, I'm going to take those 3 moles and I'll divide them all by the smallest. Well, 0.034 is the smallest. If I divide carbon by 0.034, that's 1. If I divide oxygen by 0.034, that's also 1. And then if I divide 0.046 by 0.034, I get approximately 1.3. One of the mistakes I saw frequently was students rounding this to just 1. And you can't actually do that because the ratio here is 1 to 1.3 to 1. And if you round it to 1, that doesn't keep the same ratio. So when you get to a point where this is not whole numbers, you multiply by whatever factor it takes to make them whole numbers. And if you have 1.3 that's essentially a repeating 3, which this is, if it's a 0.3 ending, then we're just going to triple everything. And so if I multiply this by 3, I get 3. This one by 3, I get 3 again. If I multiply this guy by 3, I get 4. So now I have whole numbers, and that means the empirical formula is C3H4O3. However, that's not actually what the question's asking. It's asking for the molecular formula. So we need to take the extra step because they tell us what the molar mass is here at the beginning. And we need to figure out how many times the molar mass of this empirical formula will divide into the molar mass of the molecular formula for vitamin C. So I find when I add this all up that the molar mass of this is roughly 88.062 grams per mole. And if I divide 176 by 0.12 by that 88.062, I get pretty darn close to a whole number of 2, which means the empirical formula had been reduced by a factor of 2. So the molecular formula for vitamin C should be C6H8O6, right there. In terms of the 4 points that I scored on this one, I was looking for you recognizing that it's a 2-to-1 ratio for hydrogen to water. So I had to see that somewhere in your math. I was looking that you recognized you had to do this subtraction step to determine something about the oxygen. I was checking for your application of empirical formula, and then that you knew what to do to obtain the molecular formula. I do grade with internal correctness, which means maybe you did this step and you forgot to do this step and you did something else to obtain an empirical formula. So you would not have gotten the point for the subtraction step as long as your application of empirical formula with the ratios was correct. Then even if your empirical formula itself was not correct, you still demonstrated that you have the skill for determining an empirical formula. I would have given you the point for the empirical formula. And then again, if this is wrong, then obviously your molecular formula is going to be wrong. But if you demonstrated you knew that you were supposed to divide to figure out how to multiply to obtain molecular formula, then I would have given you that point. And College Board grades the same way. So if you make a mistake somewhere in the steps that cause future steps to be incorrect, you would lose a point for one of the individual steps. But if you have the skill and you demonstrate the skill correctly for future steps, then you can still receive the point. All right, for the next one. So some of you may have noticed that there was an error here, and I'm sorry about that. The error was that I misrepresented the charge on chromate. This should have been a 2-. However, I represented it as a 1-. I think a lot of people didn't catch that, and that's fine because I was really just checking the skill, not your ability to identify that charge there. But we should do a double replacement to obtain these products for the molecular equation. And then anything that's aqueous, we break into its individual ions. Na+, chromate. I'm going to write it as a 1- because that is how I put it in the problem for you guys. My apologies. Silver chromate is a solid, so it does not ionize. and then Na plus and NO3 minus. Be very careful because I was seeing several students not include the charges here. If you don't include the charge, you're not writing that as sodium the ion, you're writing it as sodium the element, which is not correct in this context. So make sure you're including the charge. And then lastly, for the net ionic, we had this guy. Woo! 4 as a solid. Main mistake I saw in here was not everybody read the full question. So simply crossing these things out was not enough, because if they ask you to identify something, you need to identify that thing. So you needed to say the spectators are Na plus and NO3 minus. In terms of the points that I was scoring for, just checking on your ability to swap some cations and anions to produce products appropriately. Somewhere in here I was checking, did you apply solubility rules correctly with that? And then did you read instructions, and do you know what a spectator ion is? Those were the things I was looking for there. 3 points. On this last one, we have a hydrate, which looks like this. We just don't know what that coefficient is on the water. We heat it, and when you heat it, the water goes away, leaving you with this dry Na3PO4 and then some amount of water that gets lost as a gas. The data tells us that this started out as 4.05. We end up with 3.32 grams. The way we figure out how much water was lost, you simply subtract, and we get 0.73 grams of just the water lost. Since we're trying to figure out the ratio of Na3PO4 to H2O, we're going to convert both of these things to moles. So 3.32 grams of Na3PO4 divided by its molar mass, which is 163.967, give or take. Please don't get upset if your molar masses don't match mine exactly. It depends on what periodic table you're using. I use the one on my wall. The blue one only rounds out to 2 decimal places, I think, so they're slightly different. This comes out to be 0.0202 moles. Do the same thing for the water. Oop, I don't need that. This is 0.0405 moles. Now that both my moles are in, now that both my substances are in moles, I'm going to divide by the smallest. 0.02. This guy is a 1. This guy is a 2, which tells me that for the Na3PO4, the coefficient on it is a 1, and for the water, the coefficient is a 2. So the formula of the hydrate is Na3PO4, big fat dot because it's a hydrate, 2 H2O. And of course, the 2 things I was looking for there were, did you know how to find the mass of the water by subtraction? And then were you able to come to that conclusion? So if you still have questions, make sure you get those cleared up before you try and attempt the test, because some of these things are assessed in the exam. And then make sure you take the exam before it expires on Friday.